Hello students, we are going to discuss paper 13 today. The topic was current, electricity and thermal and chemical effects of current. In the first question, it is given that current passing through a conductor is 5 ampere. We want to find the charge in 5 minutes. Charge can be found by using formula Q is equals to IT. Here I is 5 ampere and time is 5 minutes, that is 5 into 60 seconds. So the charge is 1500 coulomb. So option 4 is correct option. In question number 2, there are 3 resistance of 1 ohm, 2 ohm and 3 ohm respectively. We want to find the number of different values of resistances possible using these 3 resistances. Here the possible value will be 2 power n, where n is number of resistance of different value. Here there are 3 resistors, so it will be 2 power 3, that is equal to 8. So option 4 is correct option. In question number 3, 4 wires are made of same material having different length and radii. We want to find the wire having more resistance from the given option. The resistance of wire for given material is directly proportional to L and inversely proportional to area of cross section. So we can write R is directly proportional to L and inversely proportional to radius square. If we find resistance for first resistance, the L given is 100 centimeter, that is 1 meter, and radius is 1 mm, that is 10 power minus 3 whole square. So R1 is directly proportional to 10 power 6 ohm. If we find R2, the L2 given is 50 centimeter, that is 0.5 meter, divided by radius is 2 mm, that is 4 into 10 power minus 6. So R2 is directly proportional to 125 into 10 power 3 ohm. If we find R3, then length is 100 centimeter, that is 1 meter, and radius is 0.5 mm, that is 1 by 4 into 10 power minus 6. So R3 is directly proportional to 4 into 10 power 6 ohm. And R4, length is 50 centimeter, that is 0.5 meter, divided by radius is 1 by 2, that is 1 by 4 into 10 power minus 6 meter square. So R4 is directly proportional to 2 into 10 power 6 ohm. From all this value, the maximum value is 4 into 10 power 6 ohm. So option 3 is correct option. In question number 4, a circuit diagram is given containing a battery of 12 volt and 3 ohm internal resistance connected with another battery of 6 volt and internal resistance 2 ohm. We want to find the potential difference across this 6 volt cell. Let's say this point is A and this point is B. We want to find the potential difference between A and B, that is VA minus VB. First of all, we will find the current in the circuit. Here, as this 12 volt and this 6 volt battery will oppose each other. Current due to this 12 volt will be in this direction, and 6 volt current due to this 6 volt battery will be in the opposite direction. So these two batteries will oppose each other. So net EMF will be 12 minus 6, that is 6 volt. So total current in the circuit will be 6 divided by R equivalent, as I is equals to V by R. The R equivalent will be 3 and 2 are in series, so R equivalent is 5. So current is 1.2 ampere in the circuit. It will be in this direction, as value of 12 volt is more. It will start flowing from positive terminal to negative terminal. Now if we write the potential or KVL equation for this line, Let's say potential at A is VA. Now, through the battery, we are moving from high potential to low potential. So, potential is decreased by 6 volt. So, minus 6 volt. Here, current is flowing in this direction, and current always flows from high potential to low potential. So, across 2 ohm, we are losing some potential, that is minus I into R. I is 1.2 into R is 2 is equals to potential at B. We want to find potential across 6 volt battery, that is VA minus VB. So VA minus VB is equals to 6 plus 2.4, that is 8.4 volt. So option 4 is correct option. In question number 5, it is given that two identical cells are connected either in series or in parallel across 2 ohm resistor. Let's see, EMF of this resistor of this cells are E and their internal resistance is small r. In first case, they are connected in series with the 2 ohm resistor. In series with another cell identical. And in the second case, they are connected in parallel with 2 ohm resistor. This is 2 ohm resistor. This is one cell of EMF E and internal resistance R, another identical cell. It is given that in both the cases current is same. So we want to find the internal resistance of the cell. Let's say current in both the cases is I through 2 ohm resistor. First we will find the current through this circuit. Here, as E and E are connected in series, the net EMF will be 2E, and this R and 2 ohm resistor are in series, so R equivalent will be 2R plus 2, that is equals to I, as I is equals to V by R. In second case, these cells are connected in parallel. They both have same value, so net EMF will be E only. The equivalent resistance of the cells will be R by 2, as R and R in parallel, so R by 2, and they will be in series with this 2 ohm plus 2. This is the net resistance. As given in question, these two current are same, so we can write 2E divided by 2R plus 2 is equals to, take the LCM, it will be 2E divided by R plus 4. This 2E will get cancelled out, so we can write 2R plus 2 is equals to R plus 4. So R will be equal to 2 ohm. So internal resistance of the circuit is 2 ohm. So option 1 is correct option. In question number 6, two electric bulbs whose resistance R1 and R2 are in the ratio of 1:2. They are connected in parallel to a constant voltage source. Let's say this is constant voltage source V. A bulb of resistance R1 and R2 are connected in parallel across the source. We want to find the ratio of power dissipated across them. Here, as these two are connected in parallel with the voltage source, the potential difference across both the bulb will be same. The power dissipated can be given by V square by R. As potential difference across both the bulbs are same, we can write P is inversely proportional to R. So P1 by P2 is equals to R2 by R1 is equals to 2:1. So option 3 is correct option. In question number 7, a 5 degrees Celsius rise in temperature is observed in a conductor by passing some current. Let's say 5 degree rise is due to current I1. When the current is doubled, that means I2 is equals to 2I1. We want to find the change in temperature. Here According to Joule's law of heating, we can write H is equals to I square RT, and H can be written as mc delta T for given material is equals to I square RT. R resistance, time, M and C will be constant, so we can write delta T is directly proportional to I square. So delta T2 by delta T1 is equals to I2 by I1 whole square. So delta T2 divided by delta T1 is 5 degrees Celsius is equals to I2 is 2I1. So 2I1 by I1 whole square. From this we can write delta T2 is 20 degrees Celsius. So option 3 is correct option. In question number 9, for the given circuit having a cell of 4 volt and internal resistance 1 ohm. Remember, the internal resistance of the cell is always connected in series with the remaining circuit. The resistance 2 ohm, we want to find the equivalent resistance of the circuit. First, we will start by solving these two. 2 ohm and 2 ohm are in parallel. For parallel, let's say their equivalent is R1. So we can write 2 into 2 divided by 2 plus 2. That will be 1 ohm. Here we can use the direct formula as if n equivalent resistance of value R are connected in parallel, then their equivalent will be R by N. Here R is 2 ohm and there are two resistors connected in parallel, so 2 by 2, that is directly equal to 1 ohm. If we redraw the circuit, it will be like this. This 2 and 1 are in series, so that will be 3 ohm. This is 1 ohm and this is 4 ohm. The current will start in this direction and same current is flowing through all three resistors. So all three resistors are in series. So R equivalent of the circuit will be 4 plus 3 plus 1, that is equals to 8 ohm. So option 3 is correct option. In question number 10, the temperature coefficient of resistance of platinum is given as 3.92 into 10 power minus 3 per Kelvin at 20 degrees Celsius. That means T1 is 20 degrees Celsius. We want to find the temperature at which increase in the resistance of wire is 10%. Let's say initial resistance at 20 degrees Celsius is R1. So R2 will be 1.1 R1 at temperature T2. We can write R2 is equals to R1 1 plus alpha delta T, that is T2 minus T1. R2 is 1.1 R1 is equals to R1 1 plus alpha T2 minus T1 is 20 degrees Celsius. So 1.1 is equals to 1 plus alpha T2 minus 20 degrees Celsius. This will be 0.1 divided by alpha is equals to T2 minus 20 degrees Celsius. Simplify this, we'll get T2 minus 20 degree is equals to 25.51. So T2 will be 45.51 degree Celsius. So option 2 is correct option. In question number 11, the current through a wire is given by the equation I is equals to 2t plus 1 ampere. We want to find the charge flowing through it from t is equals to 0 to t is equals to 5 seconds. Here current is the function of time, so to find the charge we have to integrate it with respect to time. So Q can be written as integration I dt limits from t1 to t2. So Q will be 2t plus 1 dt limits from 0 to 5. So Q will be integration of t is t square by 2. This 2 and 2 will get cancelled out. So that is t square integration of dt will be t, limits from 0 to 5. So q will be 25 plus 5, that is 30 coulomb. So option 3 is correct option. In question number 12, a current flows in a wire of circular cross-section area with free electrons traveling with drift velocity is equals to V. Same amount of current is flowing in a wire having twice the radius. So R1 is equals to R, then R2 is equals to 2R. I1 is equals to I2 is equals to I. We want to find the drift velocity in the second case. Current is given by NEVDA, where Vd is the drift velocity. Here current is same in both the cases, so we can write a drift velocity is inversely proportional to area. So Vd is inversely proportional to R square. So V dash by V is equals to R divided by 2R whole square. So V dash will be equal to V by 4. So option 3 is correct option. In question number 13, the 6 resistance each of value 12 ohm are connected as shown in figure. We want to find the equivalent resistance between A and B. We can solve this question by two different methods. First method, this 12 ohm and 12 ohm are in parallel. If we combine this two wire, we can see these two are in parallel. Same way, these two are also in parallel. So 12 parallel 12 will be equal to 12 by 2, as their value is equal. The equivalent will be 12 by 2, that is 6 ohm. So we can redraw this circuit as this is 12 ohm. The equivalent of this two is 6 ohm. Equivalent of this two is also 6 ohm, and these both are in series. And the third one is 12 ohm. Now we can clearly see from the circuit diagram the 6 ohm and 6 ohm are in series, so their equivalent will be 12 ohm. This 12, 12 and 12 are in parallel, so RAB will be 12 divided by total number of resistance 3. That will give us the answer 4 ohm. The second method is by using symmetricity. If we consider this point P, we can divide this circuit into two equal halves, the above half and below half. It is the mirror image of the above half. So current in these two are same, and current in these two are also same. So we can redraw the circuit as 12 ohm. This is 12 ohm. This is 12 ohm. As current coming in this will directly pass to this 12 ohm, there is no current division at this point, so we can remove the junction point. This 12 and 12 are in parallel, this 12 and 12 are in series, so their equivalent will be 24. So we can redraw the circuit as 12 ohm in parallel 24 ohm. Same way, this is 12 ohm and in parallel 24 ohm. This is A and this is B. Now this 4 are in parallel. First we will solve this 2. 24 parallel 24 will be 12, and 12, 12, 12. These 3 are in parallel. So again RAB will be 12 by 3, that is equals to 4 ohm. So option 3 is correct option. In question number 14, for the given circuit diagram, we want to find current I and the current through this ammeter. Here we can rearrange this circuit diagram. If we fold this in the downward direction, this 4 ohm and battery 2 volt, and this 4 ohm, 4 ohm and 4 ohm, all three are connected in parallel. And this is current I. To find the current I, first we have to find the R equivalent. As these three are in parallel, their equivalent will be 4 by 3. And it is in series with this 4 ohm. So R equivalent will be 4 by 3 plus 4. This will give us the answer 16 by 3 ohm. So total current flowing in the circuit I is equals to V by R, that is 2 by R equivalent, that is 16 by 3. This will give us the answer 3 by 8 ampere. Now we want to find the current through the ammeter. From this point, the total current flowing is 3 by 8 ampere. At this point, current will divide into 3 parts. As these 3 resistance are equal, the current will be divided equally. So from this ammeter, current flowing through will be 3 by 8 divided by 3. Let's say that current is I. So I through the ammeter will be 1 by 8 ampere. So option 1 is correct option. In question number 15, it is given that a wire of resistance 20 ohm is bent in the form of a square. Here we know that R is directly proportional to L. So there are 4 sides. So resistance will be divided into 4 equal parts. So resistance of each side will be 5 ohm. We want to find the equivalent resistance between the ends of diagonal. Let's say this is point A and this is point B. We want to find the equivalent resistance between A and B, that is RAB. If we connect battery between A and B, then current will flow in this direction. At this point, current will be divided into 2 parts. Let's say this is I1 and this is I2. This I1 will flow from these 2 resistance and this I2 will flow from these 2 resistance. As current is same in these 2 resistances, they are in series, and same way this 5 and 5 are also in series. So RAB can be written as 5 series 5, that is 10. This is also 10, and as current is divided in these 2 parts, they both are in parallel. So RAB will be 10 by 2, that is equals to 5 ohm. So option 2 is correct option.